So this is design patterns for the Patternless. I'm Marc Zeedar. I'm the publisher and editor of XDev magazine. I've been publishing, it's the only publication devoted to Xojo. Been publishing it since 2002, very long time. And I'm here to talk about a topic that I know nothing about. I thought I would give myself a challenge and talk about design patterns, which is something that I've been curious about for a long time. It's a huge, huge topic if you've known anything about it. Lots and lots of design patterns, lots and lots of things to learn. And I really didn't know that much about it, and I thought that would be good to talk about. So one of the things I learned exploring this is just how important design patterns are extremely linked with object-oriented programming. So you have to understand object-oriented programming, the basics of it, and all that in order to use and understand design patterns. So before I get started, let me just ask you, how many people here use design patterns? Okay, good amount, but not everybody, that's good. At least some people will learn something. How many of you use object-oriented programming? You consider yourself very versatile in that, experts, or just you use it because it's part of Xojo, or? So what I'll do real quickly, I'll just kind of go through a little bit of the basics of object-oriented programming, just because it helps to get a firm understanding of what that's about, because you kind of have to understand that in order to understand design patterns. So the first thing that I came across that I realized that the main purpose of object-oriented programming is to help you manage change. Change is the one thing that's always going to happen with all of our programs, right? Whether it's the client, whether it's you yourself deciding, oh, I want to add these new features. It's easy to get a program just working and running and doing what you initially wanted it to do, but it's much harder to write the program so that you can come back later and expand it and make changes without having to rewrite the whole thing a second or third or fourth or fifth or 10th time. So object-oriented programming is one of the biggest ways to help manage that. It helps you manage change. And design patterns, really, that's what they're designed to do. They help you set up your program so that it's easier to manage the inevitable changes that come later on as you're working with stuff. So one of the ways they do that is help you decouple your code. So we've all heard of spaghetti code. We've probably written some spaghetti code. I know I have a lot in my time. And spaghetti code is just where you have a lot of different parts of your program that are coupled together. So anytime two objects basically talk to each other, they're linked, they're basically considered coupled. And when you come back later and you make a change to one, it can affect the other one. And then the more things you've got all connected, the more you end up with a mess like this wiring diagram on the screen. And what we really want is something like the picture on the right here, where everything's kind of going through a central hub, and there's not a lot of connections, and you can independently change different parts of your program without breaking everything else. And design patterns will help you with that. OOP is also really good for helping you encapsulate your code, which again means the code that you want to change is just in one section. You're not having to change it throughout your entire program. You can say, for example, hide your data structure within that. So some of the key OOP features that we need to look at, okay, is abstraction, which is basically just the metaphor that we use with OOP. You've got like an animal object, and underneath that you've got subclasses of a dog and a cat object, things like that. So it's not literally a dog and a cat or an animal, but we just use that as a metaphor to help us understand the structure and the code that we're working with. Inheritance, we're all familiar with that, where you've got a super and you've got the subclasses. When I first started working with OOP, and especially when I was learning about design patterns for this presentation, I was thinking, you know, inheritance is the key thing with object-oriented programming. But actually, inheritance has a lot of limitations, because with inheritance, you're always stuck with that. Whatever the super is, that's your main object. And everything that's a subclass of that is still has the features and it's part of that main object. It's not a completely different kind of object. What's really powerful is about object-oriented programming is what's called polymorphism. And that's where you, in Xojo you use it with interfaces. And the idea of an interface is kind of like this Groucho Marx disguise that I have here. You're basically taking an object, putting on a disguise, and now it looks to the rest of your program like a completely different object. That is super, super powerful. How many of you use interfaces? Quite a few, good. If you're not familiar with interfaces, I really encourage you to learn more about them, because that is the key thing for a lot of these design patterns. You take an object, you put an interface on it, now it looks like a different object to the rest of your program, And most of these design patterns depend on that because that's what allows you to take, say, two different objects that do two completely different things, but to the rest of your program, they look like the same thing, and you can have two different behaviors based on which object is being passed. But you don't have to change the code of the rest of your program because it thinks it's just one type of object. And the other one, of course, is encapsulation is a key feature of OOP. So what are design patterns? This is kind of where I initially was thinking I'd start the presentation, is just trying to get into what design patterns are, but I actually decided what I really want to look at is what design patterns are not, because I had some interesting fuzzy ideas about what design patterns were when I started researching this, and I realized, those weren't really quite right. Design patterns are not algorithms. Algorithms are more like a recipe, right? They're a step-by-step code that you're going to write that's going to do a certain function. They're not like a plugin that you just stick in your program and something changes. They're not like a template where you can just fill in the blanks and all of a sudden stuff works. That's not a design pattern. And they're not like a blueprint, which is a hard structure that's you're going to program your program just within that hard structure. Okay? Design patterns are much more fluid than that. And that's actually what makes them really, really cool, because they're much more flexible. But they're also, that makes them kind of harder to grasp. I came up with 3 different terms for what I think design patterns are. They're basically sort of a guideline. They're kind of a technique. But most importantly, I think they're more of a strategy. And I used an image here of chess on here because I really think it's more like that, right? So when if you come up with it, you're going to play a game of chess and you say, I got a strategy, I'm going to do this to win. You don't just do that on the first move, right? You don't just start off with the first move and then start doing whatever you want, right? Your strategy has to continue through the whole chess game, and that's what a design pattern is. So you start off thinking, I'm going to structure my program using this design pattern. You need to continue that throughout the program. You can't just stop halfway through and kind of abandon that. So design patterns actually sort of came about accidentally. What happened was the people that were studying other programmers way back when, and they just saw that this group of programmers solved a program this way, and these people had the same kind of problems, but as a completely different project, and they solved it this way. And they started analyzing exactly how they solved it, and they came up with names for those techniques and those strategies, and that's what we call design patterns. And by naming them, it just gives us a way to communicate. So I can say, hey, I'm using the factory pattern in this, and you go, I know what that is, and it works this way, and I get an idea of how you're doing your program. So design patterns are not a magic or cure-all. You just do something and now your program is going to work perfectly, right? That's not a design pattern. They require planning and discipline to use. You have to constantly be thinking, I'm adding this feature, I'm doing this thing, I'm adding this code. Is that going to break my design pattern? Am I going to completely change it? And like I mentioned earlier when I was using the chess example, you can't just half use a design pattern. You have to continue to focus on it, and that's why I also use the word discipline here. You have to be disciplined and always be thinking about how you're using the design pattern, that you're still using it correctly. Because if you start wandering off and sort of violating the design pattern's principles, you might as well not be using the design pattern because you're not going to get the benefits from it. So what are some of the benefits of design patterns? Well, it makes your code more reliable. It allows some more reusability. It's a simpler program and structure and clarity. I would say you have more code in your program, but the purpose of that code is more clear. It allows for a lot of flexibility, better code encapsulation. Big thing is it forces you to use a more object-oriented design. You cannot use design patterns without object-oriented programming. So basically, if you're using a design pattern in your program, you're automatically using a lot more object-oriented, programming concepts. And it also forces you to decouple your code, because that's one of the big advantages and features of design patterns, is to help you decouple your code. So when should you not use design patterns? Well, you don't want to use design patterns on a small program. Okay, if it's a one-time use program, a simple program, you're just going to add a lot of extra layers and complications and code to your thing, and not really going to see any benefits. Okay, design patterns really are effective when you've got a larger program that you're going to want to come back and expand and add features to later. that's when they're gonna pay off. Same reason if a program's not gonna change, you don't really need design patterns. And you also, don't want to use design patterns just to look cool, right? Just because everybody else is using design patterns and you want to say, hey, I'm using the cool new buzzword, right? So generally when we talk about design patterns, there are 3 different categories of design patterns. And I'm just gonna talk about 3, one example from each of these categories. So you have behavioral, structural, and creative. And so what I'm gonna do today is I'm gonna show you, most of this is gonna be demos that I'll show you in Xojo. So we're gonna look at, the example I'm showing for behavioral is kind of like how you're controlling how the program flows, the structure program. So the example that you use for that is an Iterator design pattern. We're gonna look at the Decorator pattern to look at the structural, which is kind of how you organize your code. I really don't like the name Decorator. It's also called a wrapper, and I think that's much clearer, and I'll get into that when we talk about that one. And then we're gonna look at the factory pattern, which helps you create objects. That's part of one of the creative design patterns. So, like I said, most of this is gonna be some demos. So I created 3 different demos, and we're gonna look at those now. So we'll start with the Iterator pattern. This is a really simple one. It's actually, the interface for this is actually built into Xojo, so it makes it really easy to use. And an iterator is just simply, we're all used to like, basically an iterator in something like a simple structure like an array, right? It's just a list. You have an index that can access it, and you just increment the index, and you can, go down through the object. But what if you had a much more complicated or a custom data structure like a tree, or just anything else that you came up with for your particular program that does not have a set order, that something outside of that structure would know how to follow that. That's where an iterator comes in, because basically you're setting up a standard and saying this is the way an iterator operates, and I'll show you that in a second here. And basically it allows the rest of your program, without knowing anything about the data structure, how to iterate through that data structure. So let me switch over here to Xojo and find the iterator example. There we go. So hopefully you can see that there. I tried to make the font sizes as big as possible, but I can zoom in. So what I've got here is I just created a little a custom class called weekday class, and I'll show you the constructor. Well, actually, it goes to init here. Basically, this is just the days of the week. And I just, for this particular, this is just a demo, I just put it into an array, but it could be a tree or whatever kind of data structure you want. But the main idea is if you just had a bunch of days of the week and you don't know anything about, how those are organized, how would you know how to iterate through them, right? So what we do is we go over here on this class, we click the interfaces, we choose that, and you can see I've check marked the Iterator class there, or interface there. And what that does is that mandates that we have to have 2 methods. We have to have the move next method, which just advances basically the index to the next value, and it can't go past the end, so we make sure that it won't go past the end of that value. And then there's a value method that returns a variant. In this case, it's going to return the actual day of the week. So let me just run this program real quick, and I'll show you the interface. It's very simple. All it does is at the top, it displays the current value, and you hit next day, and it steps through those, right? And if we look at the actual code for that button, all it's doing is calling that move next, and move next returns a Boolean, says there is another value or there isn't, and if it's true, then we update the display, which displays that value. So you get to the very end. I added a reset counter here so we can do it a second time. We can reset it back to the beginning. I also put in here a button that says sort. So if I click that, it's going to alphabetize that list, and now it goes through alphabetically, which is a completely different sort order, and it looks very strange. And if we reset it, it goes back to Friday, and we go through like that. And I just did that to show you, like, it's some arbitrary data that's some weird order, and we don't know how it's organized, but we can still step through it using an iterator. And the cool thing about this is you can take this iterator interface and you can apply it to any object, and now you have a way to talk to that and iterate through the pieces of data, whatever the structure is. So if it's a tree, You could go through, start at the edge of the trees or start at the root and go down, however you wanted to structure that in terms of dealing with that data. So that's the iterator pattern. Like I said, that one's very, very simple. But I thought we'd start off simple. We'll get a little bit more complicated with the decorator pattern. And like I said, I don't like to call this decorator. Decorator, when I first read about this, I think decorator, I'm thinking it's like a style sheet in a word processor where you can change the font color and stuff. And I'm going, that's not what it is at all. It's also called a wrapper pattern, and I like that name a lot better because what we're really doing here is the decorator pattern allows you to wrap an object so that you can wrap several objects in this, and they all look like this object, even though they're these other objects. So the advantage of this is this allows you to flexibly run alter behavior at runtime, because you can just put in a different object there. But it can get a little confusing, as you'll see here in a second, because we're adding a lot of overhead to our code here. So, well, let me just run this real quick, and I'll just show you before I show you some of the code. So I'll zoom in here so you can see this a little bit, my wonderful demo. So I actually read a book on which I'll give you the link to later, on design patterns, and they used this example, and I just kind of thought it was a cool example for the decorator wrapper pattern. What they did is they created a file, an object that knows how to read and write some text to disk, right? It just has literally a read data and a write data methods. And that's all it knows how to do, is just read the data from disk and write it to disk. So since writing stuff to disk isn't very visual, I just switched it and made it reading and writing to text areas so we can actually see what it's doing. So if we hit the save button here, it's just going to save it onto the right field. If we actually edit the right field and do load, it's going to move it back, read it back from the right field into the left field, right? So we're just reading and saving data. But the cool thing about this is, let's say we wanted to add some extra features to this particular method. And so the example they use is encryption and compression. So for the demo, I didn't want to use actual encryption in demo, because that just confuses things. So what I did is I just used the hex feature to pretend it's encrypted. So if we hit save, we end up with hex on the right. And we can uncheck this and put in compression. I use base 64 for compression. And you can see it actually works in reverse also, although there's some weird, I think it's because I edited that. You can also do both of these together. So if you do that, you end up with that, and you load it back, it comes back. So basically, that seems fairly simple. You're like, well, I could do that a lot of different ways, right? But the advantage of this particular approach is we've actually created a bunch of different objects. So the first one we'll look at, well, let's look at our data type. This is our interface. So I like to use the word type to indicate an interface, just because it reminds me that it's not really a class, it's a data type. And so it has, when you're creating an interface, it has basically the method calls the declarations, but there's no actual code in an interface, right? It's just saying these are the required methods for this interface. So then we have several different data classes. We have this one called file data class, which normally this one in the example in the book, this would read and write to a data file on disk. I'm just doing it to the text edit, to the text areas. But then we have the actual decorator pattern class, which basically is part of the data source type. If we look at this, I can zoom over here and show you. If we click on the class, you can see I've set it to data source type. So it has that interface applied, which means it has to have the read data and write data commands. But what's interesting here, you'll see this is actually under our constructor here. It wants a data source type as its source. So what it's doing is this one here doesn't really have any brains. It's actually getting its brains from the file class that actually knows how to read and write to disk, right? So if we use this particular class, it would work exactly like the file data class that's reading and writing to disk. But then what we're going to do is we create two subclasses of that are also the same data type. One's called encryption. And again, I'm actually doing decode hex and encode hex. But you'll see here we have another line of code here that we're calling the super, that writes the data. And so what happens is the code, the text that's passed to it gets encrypted first, then it calls the super, which actually reads and writes it to disk. And this allows us to basically, we can add as many of these extra tasks in the middle of our data stream as it's being written and writing to disk. And so the compression one works the same way, except that it's using base 64. And if we go up here to look at our, we'll look at our save label. So this is the button in the demo where you press save, right? So it's going to save the data. So what it does is it creates a new data source, Decorator, and it passes one of the file class objects to it. So now it knows, because it's being passed that, it knows how to read and write that data to the disk. And that's the variable I divided as ds for data source. And then down here, we look and say, well, if both compression and encryption are check marked, or are true, then we're going to create a variable for compression and another object for encryption, and we pass those variables, those names to each of those, and then we call write data. And so what happens is this creates a whole chain of objects where the first object is doing the compression, the next, or encryption, then the compression, and then finally it's writing it to disk. And then we just do the reverse happens automatically on the other side when you're looking at the load string. And we check over here to see if only one of these is done, then we only add the encryption or the compression decorator. So the advantage of this is basically by creating a bunch of different objects, instead of having all of our code in one object, we've got multiple objects, each one is doing a specific thing. So if you wanted to come back later and say, change the compression algorithm or the encryption algorithm or whatever, you can do that without modifying any other code. And you can have the user automatically be able to change the behavior of this read and write text feature on the fly while the program's running. You don't have to predefine and set all this stuff. So that's because you've got all these objects that are wrapped in this decorator pattern. So that makes sense to everybody? Let me jump back to my presentation here. And like I said, it can get a little confusing with all the wrapping stuff, but I think it really adds a neat factor for that. So last example I'm going to talk about is the factory pattern. And factory helps you create objects. When I first heard about factories, I was like, why do you need help creating an object? You can just do new object, and you got a new object. But here's the thing. If you have your code that's creating the new object, it has to know what type of object that is, right? He's saying, I need a new X object or Y object or whatever, right? It has to know what that is. If you use a factory, the factory can create whatever kind of object it wants, and that code no longer has to be coupled to the type of object you're creating. The factory is tied to the type of object you're creating, but not that external code. All it has to return is basically a generic object of whatever type you want it to work with, right? And I'll show you an example. You'll see that at work, and it's actually really, really cool because it means that your outside code doesn't have to know anything about those objects. And that helps you decouple your main code from the actual data structure and whatever you're doing. So like I said, this makes it easier to expand and add features without having to modify your external code. So I'm going to show you some examples of some bad code because I find I learn more from bad code than I do from good code. I see good code, I'm like, wow, it's beautiful. I don't know, how they wrote it or whatever, but it looks neat. I don't really learn that much because it's already done for me, right? When I see bad code, I go, oh, I understand that. I can see why it's bad. I don't necessarily know how to fix it. So taking bad code and learning how to fix it is very educational for me. And that's where design patterns are really cool because I actually was able to fix my bad code with design pattern. So bad code I'm going to show you is, so years ago, this is how I actually got into Real Basic back in the 90s, was I was working on a novel. I had a bunch of word processing files. When you work on a novel, you end up with lots of files, so I had, a bunch of chapters in separate files. I had research notes. I had character bios. I had just all kinds of research papers and ideas and notes, and they were just all these scattered files. And it was really hard for me to find anything. It was like, which file was that in? And I'm looking through them all. And I had this idea, wouldn't it be great if I could make my own word processor where just everything's in one file, and I can just have it all there, and it's all organized, and I can find stuff, and I can just, you know, have chapter 1 revision, chapter 2, you know, an alternate version, an alternate ending of the book, whatever. And so I created my own word processor in real basic back in the late 90s called Zeedar. And it's a very simple structure. It looks like a lot of help files or things where you got a list of labels on the left in a list box, and each time you click on one, you've got the text for that section. So imagine each of those names on there is like a chapter in your book, right? It's a separate file on disk traditionally, but this saves it all in one file. This is great. It worked great. I sold a bunch of copies. People really liked it. It was wonderful. But then I wanted to make improvements and changes on it. And I discovered I'd basically programmed myself into a corner, because I had used a simple array, a text array, a string array, with all my string sections. I called them sections in the book. So each section is, because they're not always chapters, right? They could be notes or anything. So I discovered that all throughout my program, I wanted to make the program better. So my first idea was to change that data structure from an array into a dictionary. I think when I first did it, dictionary didn't exist, but that was added to Real Basic at some point, and I really liked the dictionary. I thought, oh, that'd be great. It would work much better to use a dictionary. And I wanted to do that, and I went to do that, and I discovered that throughout my code, all throughout the word processor, I frequently just talked directly to that array of string, right? I just said, oh, this section is number 10. Go to, you know, index number 10 and change or modify that text or whatever. And so to change it to a dictionary meant like I had 50 places in my program that wouldn't work anymore. So I came up with the idea, oh, okay, I'm going to write this better. I'll get smart. I'll actually create an object that has the data inside of it. So the data structure is hidden, right? Now my program can just talk to this. It can just say, get section, set section. It doesn't have to know anything about what the actual data structure is, right? This is more object-oriented program. This is brilliant. This is going to solve all my problems, right? Well, it did and it didn't, okay? Basically, it works visually from the user's perspective. It works exactly the same. Under the hood, it's completely different. But the main problem that I ran into was that a little while later, a few years later, I was working on things and I was trying to think of what I wanted the next version of my program, my word processor, to be. And I said, well, when you're writing a novel, you end up with a lot of research, a lot of different things, and not all of it's text. You might have, say, some pictures. And you might have a PDF or a web page or a sound file. You might have, say, interviewed somebody and you have a recording of that interview. You want to stick that interview in with your text. Well, all of a sudden, same problem again. My code is completely broken because I've got all throughout my code, it's assuming everything's text, and all I've got is these get text and set text methods that now are inadequate for what I need, right? So how do you solve this? Well, you solve it with a factory. Instead of creating sections of just text like this, you basically have objects that represent each section, and you can have different types of objects, like a text object, a picture object, a sound object, whatever you want to do. I got another diagram that's a little bit clearer. So you have a section factory. It is able to create a section text class, section picture class, and whatever future data type you decide to add. And this actually works really, really cool. So let me show you a demo. So what I did for this demo, and by the way, all of these demos will be, I'll have a link at the end. You can download them and play with them yourself. So let me just run this, and I'll show you the demo first. So what I actually did is I named each window here, if you can see this, bad code, better code, and best code, just to show the 3 different examples that I just talked about, okay? So visually, they all look and work exactly the same. So you've got your sections here on the left. You can scroll through them. The text on the right changes. If you make a change on the text on the right, it saves it automatically when you leave the section. So you don't have to press save. It's just automatically, saved any changes you make to that. That looks great. It's working. You can play with that. You can do the same on this one here. This is better code. Now, actually, from the user's perspective, this works exactly the same. But behind the scenes, the first ones use an actual array that is exposed to any parts of the program is directly talking to that array. This second one here, better code, looks like it works exactly the same, except it's actually doing that protected class, and it's using get and set text methods to that class. So basically the rest of the structure doesn't really know anything about the data structure, which is an improvement, but we're still very limited on being able to expand the program. So that's when I came up with this version, which looks exactly the same. It's going to work the same way. You make a change, text looks the same like that, right? No difference, right? Except, watch this. When I get down here to section 10, we've got a picture in there, right? Now, this is a demo. I didn't actually make it so you can resize or do anything with the picture, but there's basically a picture in there. You could add capabilities and put. So what I did is for my demo, every 10th picture, every 10th section is a picture, is a photograph. So we've got different photographs in here. So you click on a section and you've got pictures in there. So basically we've got this thing, and the way it actually works is this thing on the right, instead of just being a text area, it's now a container control. And inside the container control, we have a canvas and we have a text area. And depending on the data type, it just swaps out which one is being displayed, right? So it's a picture. Now it displays a canvas with a picture, hides the canvas, displays the text area with the text. And we're going to go take a look at the actual structure of this program, which, bear with me, it's a little complicated. But so what I've actually done is, you'll see there's these three windows here, so you can, when you download this code, if you want to look at it, you can actually see the bad code and how that's done and the better code. But the example that I'm going to show you, because it uses the design patterns, is the Windows best code. And so we've got several different data classes here. The main one I want to look at is, okay, so we've got something called section class, which basically has these methods in it. It is, if we look over here, it is a type called section type, which is our interface. So if I scroll down here to our interface, you can see our interface requires these methods be added to it. So basically we've got methods specifically for the type of data that we're going to be storing in there, because we have to have some way to set that data. We also have this type object, which returns this enumerated type that I created called content type, which basically defines if it's a picture or text, and eventually we could add sound, PDFs, HTML, whatever, some new thing in the future that we want to decide to support. And basically we create, okay, so section container, that's that container control. But the main ones we want to look at here are, okay, so here's section text class and section picture class, and it basically has those methods that we were just talking about. So for the section text class, it doesn't really work with pictures, so those two are blank, but the string ones just return the actual contents, the string of that. And the picture one is going to do the same, but with whatever the picture is, right? So the text ones are blank, and it's returning the actual data hidden inside in whatever form that is. But the most important thing is this section factory here. So this is what actually generates the factory. So I have several creator things here where basically you pass it the type of content that you're trying to create, and then it creates either a text section or a picture section or whatever you're wanting to create. So we've got several different ones here, and I made it kind of flexible so you can actually pass it a picture and it'll just create a picture one automatically from the picture, which is kind of cool. If we look up here at our list box, for this particular program, the main part of the program is the list box, because that's what lets you switch between the different sections. So that's what I kind of look at as like the external code, and that's where you don't want to couple that code too tightly with your data structure and other things, because that's where you're going to run into problems. In reality, for the actual word processor, you'd have lots of places. Like, for example, say you had a find replace routine in your code, that kind of a feature, it would need to have a way to look through all those different sections and to work with them. So you'd have to have a lot more structure around this for that to work. But for right now, the main one we've got is this selection changed under the list box, which basically tells us that the user has moved the arrow key to a new section. And when they do that, basically we call get section, which is this section viewer is the container control, and we're getting whatever section it has currently active. And old selection is basically just the previous selection that we had selected. And we save old selection, we save the new selected row, and then we set that with set section to the new value. So the most important thing you can see here is this code here does not know what type of object we're working with. It doesn't know if it's a picture section or a text section. It just knows it is a section type object. So this is that polymorphism at play, right? It's using just that generic object, but behind the scenes, it could be any kind of object. So this means if we wanted to go later and say add a sound object to this, we can do that, and this code does not have to change one little bit. We don't have to touch this code. It's still going to work just the same, right? We have to change it in two spots. We'd have to add our new object, and then we'd have to go to the the section factory. Obviously, we'd have to add that new object, and then we'd have to change something in the I can find it here. The section container, which is our container control, would obviously have to change to support whatever that object is, right? If it's a sound thing, we'd have to have some kind of a sound player and let the user work with that. Make sense? But the cool thing is we can basically add new data types for this without having to change a lot of external code and a lot of, we'd be decoupled all this. And so the factory allows us to do that. If we didn't have the factory, we'd be basically having to, in our main code or wherever we're doing this, we'd have to be hard coding in what type of objects we're creating and how we're doing that. And then you're starting to couple lots of different parts of your program together, and it's going to be much harder to change in the future. So I like that this design pattern solved my problems for that. So does that make sense? The factories can create whatever kind of thing you need, object you need, and then the rest of your code just works with it as a generic object. So, so there's also, I wanted to point out that there are some design pattern examples that come with Xojo. If you haven't explored them, you can open them up under the examples, and they've got several different ones. There's even a factory one, and different types, and you can explore those. And there's a link in there on each of those that takes you to a Wikipedia that tells you about that type of design pattern, so you can read more about it. If you really want to read more about it, here's some books on it. So the first book is the Granddaddy. That's the big one that came out eons ago, and it's big, thick, and very hard to read. There's the O'Reilly book, Head First, which is a little bit easier, more friendly. And I got this one here called Dive into Design Patterns. It's a digital book online. It's about 500 pages, but it reads really good. But he does a really good job of just introducing you to design patterns, and I really like that. That's where I got the example for the compression encryption example of writing to disk. So there's links there if you want to check those books out. And finally, I've got a link to my own examples here you can download from the XDev website and explore these on your own. And that's pretty much it. So, we got questions? Hopefully I can answer them. Go ahead, Bob.
So, did you write the novel?
I actually have written 2 novels, yeah. The question was if did I write the novel, and I've actually written 2 novels that I self-published, yeah.
Okay,
so,
great, thanks.
So yeah, and my program did help me do that, yeah. But there were other obstacles too, so yes. Yes.
It's nice to use design patterns like you do, but I'm a bit afraid when the one that comes after you won't probably understand what you're doing. So then it's easy to change something for you, of course. You can grow with the design pattern, but somebody else will probably not understand. So how do I explain what I'm doing? How do I hand over the program to somebody else?
Okay, the question is basically if I use a design pattern in my project, it's easy for me to understand why I'm doing that and what I'm doing, but then the person who comes after me and looks at my code might not understand what I'm doing and that. But actually, that is one of the reasons why you would want to use a design pattern, because if it's a person who knows design patterns and understands programming, that's the advantage, because we've named it. Right? We said, I'm using the factory pattern, and you can say, I'm using the factory pattern. Here's why that person would go, oh yeah, I understand the factory pattern. I see what you're doing in this program, and this makes sense to me that you're creating it this way. And so basically the whole purpose of design patterns in that regard is to allow that to be easier for those other people to follow in your footsteps. And you can also comment and do things. Yes, Jeff?
I was just going to comment, yeah, if you put in the comments of your code that this is using the following design pattern and perhaps a link to the Wikipedia, if someone comes across it, they go to Wikipedia, read about it, and go, oh, now I understand what this is. So your code's a little more self-documented in that way.
Exactly. So Jeff just was saying that you could comment in your code and link to, say, the design pattern on Wikipedia and say, I'm using the factory. Here's the link to that description. They can see that and go, ah, okay, I see what they're doing here, even if they're not familiar with that particular pattern. And I looked into this and it's like there's so many patterns. There's a lot of variations of patterns. So there's like factory and there's like, I don't know, half a dozen different types of factory patterns and sub-factories. There's even factories that make factories. It gets really confusing. But that helps you, don't feel bad because you don't understand a particular pattern, right? But if you understand the concepts of patterns and what their goal is, I think it makes it much less scary, and you're much more able to, say, go to Wikipedia and read about that, or get some of these books, or play with some examples and go, now I see kind of what they're doing and why they're doing it and all that. And I think the why is the most important for me. I see some code and I go, well, that looks neat, it works, but I don't really know why they did it that way. It looks like it's a lot more complicated. I would do it simply, but there actually are some good reasons, for that long-term change, ability to have the program last many, many years by using those design patterns. So that's what I find, it's helpful for that kind of thing. Any more questions? Yes, Bob?
The factory pattern, so when I say, all right, give me one of those objects, is it returning a superclass or is it returning a class interface?
It's returning the class interface. Okay. So the question was, when you have the factory pattern create an object for you, what is it returning? And in this case, it's returning the interface, which is, in this case, for my example, was section type. And so because that's a generic object that could be anything underneath it, it's just any object that matches section type, that gives you the flexibility that factories could create any kind of object as long as it's a type of section. Okay. And so what that object actually does, can be, it's up to the object itself. That object can do whatever it wants. And so that helps separate what that object does from the rest of your code. And then when you have to make a change, you just have to modify that one object and how it works.
Thank you.
Make sense? You had a question?
Is there some design patterns specific to, like, let's say, a database or text or to...
Oh, okay, so that's a good question. The question is there design patterns to, like, say, databases or text or working with certain things? And I would say yes, in a way. I don't think they're not, again, design patterns are specifically, they're very broad and vague. So they're not really defined like they work with this particular type of data or whatever. They're just kind of a technique and a guideline. And so you could adapt any of them to work with a database or work with anything that you need.
Okay, but is there some design patterns that they would say do not use with, let's say, a database or recorder?
So the question is, there some design patterns you do not want to use with certain things? I would say not really. I wouldn't think that. I don't know if there's somebody who's more expert on this than me. Like I said, this is something new to me. I'm learning, but I don't think that would really matter that much. It would. You can adapt it to whatever you need to do. There might be some that are better for a particular purpose than another. You got a question?
It's just actually sort of a comment on this.
Sure.
In terms of database design patterns, there's one called active record that Ruby on Rails implements. I think that's originally Martin Fowler's got a book on enterprise integration design patterns that deal with a lot of stuff like talking to databases and that kind of thing.
Perfect. Okay, so the comment was that there's an active record data pattern, a data pattern that you could use for databases to work with that, and that makes sense. So right, yeah. So there's lots of different things you can research for different projects and different things, different needs, and some would probably work better than others. So, any more questions? All right, I think we're done. Thank you.